Okay, so welcome to the first episode of our series on building a programming language from scratch. Our goal here is to kind of like create a new dynamic scripting language, just like the Lua, Python, or JavaScript. So, assuming everything goes well, we will take this all the way to building a virtual machine that runs the bytecode our bytecode generator produces. So, and in this video, we're going to implement a minimal Lexer, Parser, and evaluator. So our Lexer will doing something like the lexical scanning. It will convert the string of characters into the token sequences, and we will using the Parser to doing the syntax analyzing. So we will using Parser to construct an abstract syntax tree. Then we will finally using the evaluator to doing something like the calculate an expression, and all the program will be written in C. So we can like first to start writing some codes. So we can create a new file. That is parser.c, and we basically create a simple hello world program. And we will use the make tool for the building process. We will create a make file. So our compiler is the CLang. We will use the running or running extra, and the C standard we will set for 17. And our target is the parser, the dependency is the parser.c, and we will use this for the compiling command. C and C flags. Okay, so let me give it a try. Okay, I forgot the C17. Okay, so our basically first program just work well. So let's we just define some basic data structure for our parser Lexer. So first structure we will need is the token, right? So we will use the type define structure and the token. Then we will define a enumerator. Type define an enumerator for the token type. And the token type have the token, I'm saying token number for the number integer literal, and also have the token plus, token minus, token star, and the token slash. Let me see. So we just pass the token type into the token. And we will have the number integer for the when the situation when type is the token number. Then we will define the abstract syntax tree node. So type define structure the AST node, and it also have the enumerator. We will define the enumerator. This is the AST node type. And we got AST variable, since we will have the different type of variables, and AST binary operator, AST unary operator, and we will pass the AST node type, and we can like create a union inside the AST node. So a union and the int value. So this is the situation where type is the AST variable, And we have the let me think. We have the AST binary operation. And when the situation is like a AST binary, we will use the struct. This is the binary operation. And a binary operation struct will have the first is the operator. Basically, it's the token type. And we have the AST node. Let me see. We have the AST node, which is a semicolon. Have the AST node. This is the pointer. This is the left node, and the AST node. This is the right node. And we also need to put the struct in the front. And we'll have the AST unary, but in this video, I think we will not use the AST unary operation. So basically, a union can only have one member at the same time, right? So I think our data structure are all defined. Then we'll kind of like create the characters we will want to do in the lexing and the parsing. So we create a chair. What's the name of this variable? In string. And we will put something like a 1, 2, 3, 4, 5 multiply 8 plus 8 and multiply 5 plus minus 2. So that's the expression we want to calculate. And we can like first create a Lexer. So Lexer is the token. We'll return a token. Get a next token, and it accepts a pointer to a pointer. We name it like a source pointer. Since we want to kind of like change the pointer that's a pointer to the, we want to change the position that the pointer points to, so we will needed the argument to be the pointer to a pointer, and we want to kind of like first doing something like skip the white space. So if the source pointer equals to white space, or the source pointer equals to the new line, or equals to the table. So in this situation, we will just drop this. We will have the infinite loop. So in this situation, we want to drop the token. No, not the token. Drop the character, and also we want to kind of like move the pointer. So we will use the source Ptr and multiply. So when the source Ptr character is like the terminator, we will break the loop. Basically, it's the end of the file. Oh yes, we should also define the token end of file. So in this situation, we will not break. We will use return and return the token. The token type is the token end of file. And we can like doing something like the parsing the number literal like this. So we'll have a way to define whether a character is integer. So we'll define a function is digit. So it will pass a character C, and we will return C greater than the ASCII 0 and C. I type wrong symbols, and C smaller than ASCII 9. So in this situation, the character is a valid digit. So we will pass doing the Lexing here. So not well. So we should first doing the if statement. If there is a digit, the current source pointer is digit. We will have the let's initialize the variable well initialize with 0 and doing the loop well well is digit. And we want to add up the value, so it's like the old value multiplied 10 plus new value, that is the source PTR. And since this is a ASCII code, we want to convert that into a integer, just minus the ASCII code 0. And we also need to kind of like add up the pointer. Let's point to the next position. So that's also, I think that's finished. Then we are kind of like analyzing scanning the symbols, minus, plus, something like that. So we will use the switch. Switch, we will kind of like switch like the source PTR pointer. In case of this is will return token, and the type is the token plus. Case minus, we will return this is the token minus, and the case slash return token slash, in the case star. Okay, finished. And let me think. Since we have the we directly return, but we should also like add up the pointer to pointer the next characters. So we want to also, before the return, we want to add up the pointer, right? Yeah, so we will kind of like put the character into a temporary variable. So we name it current source PTR, and we want to add up the source PTR. And we'll use the current, and this is also current. I think that's finished. So we can give it a try. So we have the while loop, and let me think if we should define a kind of like a global variable, like the token, current token, and if the current token equals to get the next token, we will use this in source. So if the current token dot type is equal to token end of file, we will break the loop. And we kind of like want to check out the running situation. We want to point out like the Lexer, doing the for mode. Current token, we first is the type, then is the number. Yeah, we can like yeah, I think the Lexer is basically finished. Let me give it a try. Do it like the this one. Yes, this. Yeah, we should add it the new line symbol. I think our Lexer basically running successfully. The first value is 1, 1, 3, 2, 5. its digits. Basically, first one is 1 and 1 3. We'll escape. It seems like not running correctly. 1 5. Let me see. Turn the token, we just put into the next token. We want to use the current. Yeah, so we didn't return the correctly, right? We will return. We forgot to return the value, and the type is the token number, and the number is the value. Give it a try. Yeah, we successfully doing the lexing. Let me see. So 1 2 3 4 5 is this, and 1, and the 1, and the end of. So we successfully convert the character into the token sequences. So this is the token sequences. We can have the multiply and minus. Okay, so all of them is are successful. And then we will kind of create the parser. So we have kind of the precedence for the operators, since the multiplication and the division have the higher precedence compared to the addition and subtraction. So we will handle that operator precedence. We can create a hierarchy for the building the abstract syntax tree. So that's basically the hardest point. So we want to create the parser here. When we consider the precedence, that's basically pretty hard, to be honest. You need to kind of understand the algorithm for that. So we can first create, let me think, the AST node. Parse expression. We have the expression when we have the 3-level hierarchy, right? So AST parse, this is the term. We have the AST node, and this should be return the pointer. Parse, this is the vector, basically the minimal units, and we should all return the pointer. So when we parse the vector, we will kind of create AST node, create a helper function. So we create here, right? We'll return AST node pointer. So this is AST node create number. So its arguments is the value. So it's value, and we will use AST node, and we will use the malloc locates that into the heaps in the memory side of the AST node, and we slice off the header file. We're missing the header file, so that is the std stlib stlib, and we will create the type is AST variable. The value is the value. Return the node, and we'll have the AST node. This is the AST node create a binary operator. So you will have the token type, which is the operator, and have the left node, right node, and this is the same, right? The cap is the binary operator. And we will define the union operator is the OP. The binary operator's left node is the left, and the operator right is the right. Struct assign, we cannot pointer type to struct into. Basically, they are the same, to be honest. Basically, they are the same. Let's return the node. So can we just directly, let me think, parse the factor? So this is we want to parse the literal token. So if the current token dot type equals to the token, let me think, number is the valid number in literal. So we'll return. Return what? Return something like the number, right? We will directly return the number. Return token. I'm done. Well, we will just return the create the AST node. Type the number, and we also want to advance. Yeah, we also like go next. I think we don't have the additional function for move the pointer advance. We should create a function advance. So this will move the pointer advance. So we want the token be updated in here. In. Okay, that's basically finished, and we want to do advance here. So this will consume the number literal, and when this non-valid function does not return a value in our control, blah blah. So we will, so in this situation, basically something get wrong, right? So we will just quit the program and print the error. Unrecognize the token, but we don't know what that token is. We just put a token placeholder here. And that way just kind of like create a new. So we're gonna parse something like the multiplication and division in this function. Basically, this is kind of like a secondary high precedence in this function, and we will use the AST node left. We directly using parse factor, not parse factor. Oh yes, parse factor. And we will doing the while to check if the current token dot type then is equal to token. Let me say token star, or is type the token slash. So this is a valid multiplication and multiplication and division, right? In this situation, we have the AST. We should get the AST node right from the parse factor, and we want to build. We want to build a binary operator. AST creates binary operator. We have the current token dot type, and we have the left. We have the right. That is like running. We just leave it alone. Let me think. We have this, and if we this is something like we intercept the next child AST node. So if we not intercept, it not meet our condition, we just directly return the left. But we can make the left be this, right? Let's make a lot of sense, and with the same logical in here. So we have the left Parse vector and Parse term. So well, if the current token dot type equals to token minus or current token dot type equals token plus. In this situation, we want to AST node. This is like a right is like the Parse term. The left is the create a new binary. And then we'll return the left. But we also want to kind of like consume the current token, just like what we did. In where? In the Parse vector, we want to also produce the symbols. Let me think. How can we consume that? We have the. So we have to save this kind of thing before we consume, right? Advance. But before advance, we have to save that type. So why not we directly save the current token, or we only save that type? We save that token, and this is the consume. What this is the consume like consume. For example, multiplication or slash, and the same logic in this type. And so everything should be work well. I guess. Can we dismiss this one? I remember we can doing this by such. Did I forget how can we must use tag to reference whatever? I just forget. Let me think. I think we should this. So this is all finished. I think there's no arrows. Maybe. Yeah. Yes, we should change the main loop. So we can't like using the advance. We'll use the Parse expressions, and we have the current type that loop recurs that expression. Let me give it a try. First expression, and every time the first expression, let me think. It's like a way. I don't think we need the loop here, but that will be fine, to be honest. Yes, we kind of like need to create an evaluator for this situation. Let me think. A evaluator will return a integer evaluate. So it will accept AST node. So for AST node, we can like to give the node type. So if the type is like a binary, we can like evaluate all of the left and right, right? So we evaluate the binary left, and it's like a recursive. It's the right. We have the int L and the int R, and we just kind of like check. We use a switch. This position is a switch. Switch binary operator. If it is the case, token minus. I think first is token plus. Token plus will return the value that is the L plus right. So if this will return L minus, in the case token dash return handled. So basically there's no other situation. So if our node type is the AST number variable, we just directly return the value. Let me give it a try. So how many times will this gonna intercept? 2 times. Let me think. We have the edit missing running. We didn't handle the number and our file. So we want to evaluate the AST node. Should we using the Parser expression? I don't think so. Basically, everything is finished. Our evaluator is done. Was done, but I want to kind of like evaluate. Why not directly evaluate this one? So AST node is this. I think this is redundant. Evaluate node. So this is int eval. We want to hello. One, two, three, four, five. We have the what is our integer? We have a +2. We can like make it simple enough. Something went wrong. There's a bug. Seems like we didn't. So it's definitely a Parser problem. Since we Lexer is basically work fine and we consume. So we're not like doing something same in the Parser factor. We should kind of like store that in the temporary before advance. So the number is not correctly be read. The number is like we doing the int now. And the value is better, but it's fine. Let's give it a try. 2-0. What the fuck is that shit? Let me see something like so we kind of like we seems like okay, the type I'm dumb enough. It should be number. That should be number. 1 plus. So basically it's finished. We have tried to do the a true calculator, and we're trying to like a 3 multiply 3 minus 1. So you have calculator in the right the precedence. So 2 multiply 3 is 6, and 6 9 10, and it doing in the correct precedence. So basically our Lexer and Parser finished, and I don't know why it's negative. I think it exists something. And I remember I didn't set the check in the evaluates in this situation. The R should not be the 0. So if the R is equal to 0, we will exist in the 1 in the print of this is a runtime error. Okay, so basically a pretty simple Parser and Lexer basically finished. Then we can just edit the parentheses precedence maybe for the next video, I guess.